Good morning, boys and girls. Here's lesson 9.3, Analyzing Relationships. Our objective is I can solve problems involving relationships between quantities by finding a pattern. You've been finding patterns since you were just little. Okay, we're always looking for patterns. I do believe this is probably the hardest of the 5 lessons in Chapter 9. But if you remember that all we're doing is trying to find a pattern. This lesson will also draw on your understanding of rates and ratios. Back when we did rates. So, let's go ahead and get started. First of all, I want to introduce you to, or remind you of if you've seen it before, is cubes. This is a strategy we use for story problems. Mrs. Kissel wants the whole school to start using cubes more, so I thought I should probably introduce it in our video. First of all, when you come to a story problem, the first thing you want to do is circle any numbers that you see. Numbers and operations. Then you're going to underline what the question is. What is it asking you to do? What is the question or what is the action? Whether it's write an equation, solve for J, solve for the number of hours, whatever it is. Then you're going to box any keywords. If you see words like greater than, less than, multiplied by, times, subtracting, those types of things, you're going to box those. You X out anything that's unneeded information. If it's just telling you the name of the school that the kids are working at, that's probably not important. You can get rid of it. Then you set up your problem and you solve. Let's start with this one. Sorry, my table's a little sloppy there, but I think you guys can see it. Now, the table shows the amount of water pumped through a fire hose over time. First of all, pause. Do you know what a fire hose is? A fire hose is what a firefighter uses. They connect it to the fire hydrant, and it pumps water through the fire hose. Now we know what time is. It's seconds, minutes, days, whatever it might be. If the pattern continues, how long will it take a firefighter to spray 3,000 gallons of water using this hose? So let's take a look at our table. It looks like here's our time, and it's in minutes. So in 1 minute, the amount of water per gallon is 150 gallons. That's a lot of water. Think of 150 gallons of milk coming through a water hose in 1 minute. It's a lot. In 2 minutes, it looks like that's going to double to 300 gallons of water. In 3 minutes, it looks like they're adding another 150 to 450 gallons of water. And in 4 minutes, it's pushing out 600 gallons of water. So let's go back and do cubes. First, we want to circle our numbers. In our problem, it looks like we had this number here, 3,000 gallons. So let's include gallons in that. 3,000 gallons of water. And then, obviously, we have to refer to our table as well. Now, we're going to underline the question. It is asking us how long. And long is going to give us a time. So we need to figure out what is the time. How many minutes? If you put how many gallons, that's not the question. It's asking you how long it's going to take. So you better have an answer that has time or minutes. Now, let's box any keywords. If the pattern continues, how long will it take a firefighter to spray 3,000 gallons of water using this hose? I would say let's box in. Oh, geez, I'm not very good at this. I didn't even circle correctly. Okay. Sorry, this one's supposed to be a circle. This one is underlined. And then box, let's box the word pattern. Okay, X out any unnecessary information. We don't really need this part. We already know what it means. Okay. And then let's set up and solve it. So, I need to know how many minutes it's going to take for 3,000 gallons of water to pass through the hose. I already see that for 1 minute it's 150 gallons. So my time is T. Let's see, I'm trying to think of how to do this. Let's set it up and we'll see if it works. My time is, because that's what I'm looking for, is time, 150 times G. Is that right? No, because if I do that, then it's going to give me a really big number. If I take 3,000 and plug it in here, it's going to give me way more than the number of minutes I want. So that's not going to work. Sometimes that happens. I have to set up the problem and look at it and say, oh, that doesn't make any sense. Okay, So if I try the number of T, what if I take the gallons and divide it by 150? So then I have 3,000 gallons divided by 150. That'll give me a smaller number, which my time is a small number, so that would make sense. I'm going to first cross off these zeros, and then I'm going to see how many times 15 goes into 300. 15 goes into 30 twice. And 15 doesn't go into 0. Okay, so now I've got 20 minutes. Does that make sense? Is that logical? Yes, it would make sense. It would take about 20 minutes for 3,000 gallons to be pumped through. So 20 minutes is my answer. There's a couple of ways you could do this. You could have just continued the pattern up every minute. So you could have done 5 minutes is what, 6 minutes is what. But another way you could do it is to take the number of gallons, divide it by the unit rate, the number of gallons divided by the unit rate, giving you the T time. So our answer is it does take 20 minutes for 3,000 gallons to be pumped through the... Oops, that was my workspace, but we don't need that one. Okay, here's another example. Dairy cows, dairy is milk. Dairy cows provide 90% of the world's milk supply. The table shows the amount of milk produced by a cow over time. If the pattern continues, how much milk can a farmer get from a cow in 1 year, or 365 days? So, here's my time. We are looking at days. Oops, let's get my laser out. Time is days, and the amount of milk is in liters, okay? So in 2 days, 50 liters. My brain automatically tells me, well then what was 1 day? Probably half of that. So 1 day was probably 25 liters. In 7 days, 175. In 10 days, 250. In 30 days, 750. So, let's start with our cubes. What are the numbers here? I'm just going to circle the numbers. I have 90%. I have 1 year. I have 365 days. And then I have all the numbers in my table over here. Okay? I'm going to underline the question. If the pattern continues, how much milk? How much milk? And our milk is being measured in liters. So I'm looking for an answer with the number of liters can a farmer get from a cow in 1 year. Now I want you to notice that my liters is bigger than the number of days. So in 365 days, I better have more than 365 liters. I'm going to box any keywords. Let's use this word pattern again. I'm going to X out any unneeded information. Dairy cows provide 90% of the world's milk supply. That is not important. It's a nice fun fact. We don't need it. The table shows the amount of milk produced by a cow over time. Don't need that. If the pattern continues, how much milk can a farmer get from a cow in 1 year? That's important. Okay. So now let's set it up and solve. In 1 year, it's 365 days. So I need to know how much milk is the cow going to make in 1 day, and then I can times that by 365. And that will tell me how much the cow produces in liters. That's an L, sorry. Let's just do a regular L. That will tell me the number of liters. If I take the number of days, or it produces in 1 day, and times it by 365. Is that good? I just kind of variables there. So looking at our table, in 2 days the cow produces 50 liters. So in my mind, I think 1 day, let's divide it in half. 1 day, the cow probably produces 25 liters. Does that make sense for the rest of this table? Look at this. In 10 days, it produces 250. That's 110 times 25. Yeah, that makes sense. 30 times 25 is 750. So yes, it would make sense. That's going back to the lesson in 9.2, finding a rule. The rule is X times 25 equals Y. Okay? So if I take 25 and times it by 365, it should tell me how many liters a cow produces in 1 year. So let's do 365 times 25. 25, 5 times 6 is 30, 31, 32, 15, 16, 17, 18. Okay, 10, oops, 12, 13, and 6, 7. Oh, check my math there. 9,125 liters. Sounds reasonable. It's bigger than the number of days. So that's how many liters. That's an L for liters. Liters that a cow can produce if it produces 25 liters of milk every day. In 1 year, that's how many liters they'll produce. Okay, to try it. The table shows the number of minutes that Tara practiced after D days. If Tara practiced for 70 minutes, how many days has she practiced? You're going to look for a pattern. Go ahead and solve this on your own. All right. So there's a couple of ways you can solve it. Let me show you a way that I did it. I found an equation. I said, well, the number of days is what we're looking for. If the number of days that she practiced, and we know how many minutes that she practiced, we can divide it by 35 because that's how many minutes she practices per day. So if days equals, and she practiced 70 minutes, divide that by 35. 35 is a double of 70, so she practiced 2 days. So 2 days is our answer. Another way you could have looked at that is you could have said, well, 70 minutes, she did 35, and then 105, so it probably falls somewhere in here, because it's not going to be more than this, right? And you could have found that 2 days is equal to 70. Okay? A couple of ways you could have solved that. And that's the wonderful thing I love about math, and especially algebra, is there's so many ways to solve it. Do the way that works for you. Okay, last problem for today. A group of dancers practiced for 4 hours in March, 8 hours in April, 12 hours in May, 16 hours in June, and if that pattern continues. How many hours will they practice in November? Go ahead and solve it. Okay, now I tried to think of a way to make this work in an equation. I couldn't think of one. If you thought of one, please share it with me because I would love to hear it. But what I did is I just looked for a pattern because that was our objective today anyway. Look at this. They're just adding 4 for each month. Well, if I know my months in the year, I can just add 4 until I get there. So I took June and 16, and I said, okay, June, then next comes July, plus 4 would be 20. Then August would be 24. September would be 28. October would be 32. So November would equal 36. And that's how I solved it, to be honest. I tried to think of a way to come up with an equation. I couldn't think of one. So sometimes there's ways to come up with the equation, and if you found one, please share it with me because it was hurting my brain to try to think of one. But you can also just do the maybe a little bit slower way, but find the pattern that works for you. All right, that's the whole lesson. I hope that you're feeling more confident in solving story problems using tables and filling out information, unit rates, and equations. Thanks so much for watching. Ask me questions if you need help. Thanks, guys. Bye.